आजको हाम्रो टपिक छ कङ्क्रिट टेक्नोलोजी एन्ड मसिनरीको च्याप्टर 5 कन्स्टिट्युएन्ट्स अफ मसनरी स्ट्रक्चर 5.1 मा छ मसनरी युनिट्स 5.1.1 मा छ एडप्स 5.1.2 मा छ ब्रिक 5.1.3 स्टोन 5.1.4 कङ्क्रिट ब्लक्स 5.1.5 बोन्स इन ब्रिक्स 5.2 मा छ मेसनरी मोटार्स 5.2.1 मा छ प्रपर्टिज अफ वेट मोटार्स 5.2.2 मा छ स्ट्रेन्थ अफ मोटार 5.1 मसनरी युनिट्स एडप्स भनेको सन ड्राइड ब्रिक्स युज्ड इन हट एन्ड ड्राई क्लाइमेट इट इज अ बिल्डिङ material made from earth and often organic materials. Example straw or dung. Adobe means mud brick in Spanish, but it refers to any kind of earth construction. It is the earliest building materials and is used throughout the world. Rammed earth, clay in layer, poured and puddle adobe wall. Concrete blocks made from inorganic materials, aggregates only, and cement. To construct some types of structure more quickly and economically due to the reduced amounts of mortar needed compared to other building materials, bricks and stone. Types: solid concrete blocks, hollow concrete blocks. Bones in bricks: English bond, Flemish bond, stretcher bond, header bond, quetta bond, rat trap bond, etc. English bond used in general practice, consists of alternate cores of headers and stretcher in facing. Considered as strongest bond in brickworks. For breaking particle joints, queen closure is placed after first header. Flemish bond features alternating headers and stretcher within a course, more decorative than English bond but weaker than English bond. The alternate headers of each course are centered under and over stretchers in adjacent course. For breaking of particle joints, queen closures are inserted in alternate courses next to queen header. Single Flemish bond and double Flemish bond. Stretcher bond only used for walls of half brick thickness, partition wall. To break particle continuity, 1/2 brick bat is provided in alternating courses. Header bond is used. It is used for facing of curved surface and footing in foundation. Should never be used in straight work as it is very weak. 1/2 brick bat is used at end of layer. Quetta bond type of bond used to accommodate the particle reinforcement bar used in seismic areas with minimum 1.5 thick wall. Elevation are similar to Flemish bond. Continuous quarter brick by half brick pockets are formed in which concrete or mortar is filled up with work progress. Not used so much now because of the cost. 5.2 मा छ मोटार यसको टाइपहरू के छ भन्दाखेरि मड मोटार, लाइम मोटार, सिमेन्ट मोटार, सिमेन्ट लाइम मोटार, स्पेशल मोटार. फंक्शन: बाइन्डिङ द मेसनरी युनिट्स, provide level course, provide proper shape and size. 5.2.1 Properties of wet mortar: workability, water retentivity, rate of stiffening, strength, resistance to rain penetration, durability. Workability: ability to be spread and applying to masonry unit with ease and proper filling of masonry joints. Good mortar hand from trowel and flow down with light jerk. Finer the binding materials, greater the workability. Clay soil is greater than sandy soil. Lime mortar is greater than cement mortar. Mortar with well-graded sand has better workability than one made from ungraded or poor-graded and coarse sand. Lean mix and angular sand has poor workability. Workability can be increased by adding admixtures. Water amount. Water retentivity. To hydrate to hydrate cement or to gain adequate strained water is necessary. Water absorbing capacity of masonry unit depends on porosity and moisture content. Mortar with fine and graded sand has good water retentivity than coarse and ungraded sand. Addition of lime and plasticizers improve water retentivity. Good workable mortars have good water retentivity. Should not less than 70% water retentivity as per standard test. Pre-soaking of masonry unit. Rate of stiffening. Rate of stiffening. Stiffening of mortar is due to either by loss of moisture or by setting action of binder used in mortar or by both. Mud mortar stiffens only by moisture loss. Mortar should have sufficient rate of initial stiffening to proceed construction work at reasonable pace. Low rate stiffening mortar will get compressed and squeezed out due to self load of masonry, resulting variation of mortar thickness, distortion of masonry. High rate of stiffening results cracks. If rate of stiffening is too rapid, it will result in cracking of masonry by shrinkage. Cold climate, high rate addition of insulator. Hot climate, slow rate acceleration of retarders. Strength. Mortar gains strength in small extent by loss of moisture due to drying action and mainly by setting action of binder, lime and cement. Mud mortar has low strength, softened and eroded by rainwater. Suitable for superstructure, temporary structure and light loadings. 28 days consideration for full strength gain. Strength of masonry mainly depends on strength of mortar. High strength mortar has advantages only in case of high strength units and heavy load. Compressive strength, tensile strength, shear strength, bone strength. Resistance to rain penetration. Rainwater penetrates a masonry wall by three modes. That is through pores of masonry units, through pores of mortar, and through cracks between unit and mortar. Main source is crack in masonry. Rain penetration is much more through wide cracks, even if few in number, than through more number of thin cracks. Crack is result of improper bond between mortar and units and by shrinkage of mortar. Not very strong mortar, slow rate of strength gain and good bone strength results less and thin cracks. Durability. Deterioration in mortar takes place due to frost action before sufficient strength gain and repeated cycles of freezing and thawing. Chemical actions mainly soluble sulfate, movement of moisture and weathering, alternate drying and wetting. Should gain strength rapidly, should have sufficient proportion of cement and proper grading of sand. Use of admixture. Use of rich mortar or composite cement, lime mortar, keep dry. 5.2.2 Strength of mortar NBC 109 degree 1994. Optimum mortar mixes for maximum masonry strength with masonry units of various strengths. Masonry unit strength Newton per mm square mortar type below 5 M2, 5 to 14.9 M1, 15 to 24.9 H2, 25 or above H1. NBC 202 degree 1994. Half brick wall 1:4 cement sand mortar, 1 brick wall 1:6 cement sand mortar. High strength mortar has advantages only in case of high strength units and heavy load. Minimum compressive strength at 28 days Newton per mm square mortar type 10 H1, 7.5 H2, 6 H2, 5.0 M1, 3.0 M1, 3.0 M2, 2.0 M2. Strength of masonry. Strength of masonry depends on strength of mortar. Strength of mortar depends on the quality of cement, sand and mix proportion. Water cement ratio affects on the strength of mortar. Curing is compulsory to achieve high strength of mortar but not in mud mortar. Measured strength is compressive strength, crossing or compression test of mortar cube. Bond strength, tensile test, shear strength, diagonal shear test, triplet test, non-destructive test, penetration test, rebound hammer test, etc. So chapter 5 को कन्टेन्टहरु यति नै हो. So thank you.